Oh, they're just time consuming.
Okay.
I was like, I feel like something's missing, but I guess that was all the notes.
Oh wait. Oh, physics. Sorry, I'm like late to this because I was taking my.
Oh, that's right.
It's like, whoa, wait, I know what these things are.
All right, so in exercise 1 through 8, the function v of t, so is velocity in meters per second. Thank God they didn't do foot pounds or something crazy.
Yeah, I did hear that. I was very confused.
Yeah, of a particle moving along the x-axis. Use analytic methods to do each of the following. So part A says to, I'll write it out for the first one, and then after that, I'll just reference it as A, B, and C. Determine when the particle is moving to the right, to the left, and stopped. So, here, let me write above what the actual problem statement is for number 2. V of t is equal to 6 sine of 3t. 0 is less than or equal to t, less than or equal to pi over 2. So that's the actual problem statement for number 2, and then this is part A here. So I'm going to take, to determine when it stopped, that's the easiest thing. So that's setting the velocity equal to 0, right? Because that would mean it's not moving, so it's got to be stopped. So I'm going to say 6 sine of 3t is equal to 0. This means that the sine of 3t is equal to 0. Now, in general, okay, not specific to this problem, but where is sine 0? When the angle value is what?
90.
That would be 1. That's y value.
When the angle value is 0.
When the angle value is 0. So what does that mean for this specific problem? What has to be equal to 0 from what I have given for the angle to be 0? 3t would have to be equal to 0. So I can eliminate sine altogether and say 3t is equal to 0. Now, where else is sine 0?
180.
180 or pi, because we typically use radians for calculus. Yes, same thing. So it also would be when 3t is equal to pi.
Okay.
So this has the angle is equal to 0. The other option, 3t is equal to pi, because that's the other place where the angle causes it to be 0. So
Are you solving for when position is 0? When it's stopped? Is that what we're doing?
Yes.
Is that because it's like the easier of the two to do?
Yes. Well, stopped is the easiest thing to find, and then after that we'll just be determining left and right, which is a lot easier to do once we have the stopping points. So this means that t is equal to 0, or over here t is equal to pi over 3. So here, this is where it is stopped. So not moving at all. So I'm going to have 2 intervals. Obviously, it starts at time 0. Okay. 0 is less than or equal to t, less than or equal to pi over 2. So now using these 2, stopping points, obviously it stopped when it's initial, because the initial would be 0. But I'm going to use the pi over 3 to create 2 intervals, and then I'll determine on which interval is it moving left and which one's moving right. And I guess it is possible that it could never be moving right or never be moving left, but I think in all of these ones there's a left and a right. So then that means that my intervals are going to be 0, less than t, less than pi over 3. Make sure they're not or equal to intervals. No, they're not. Okay.
How do you know if it's like less than or like less than or equal to?
Part of it would be what's up here. So I guess technically this one should be less than or equal to because that was what was given to us to begin with. But the pi over 3 is actually disregard that because it's stopped at 0. This one t can't be equal to 0. Pi over 3, that's another stopping point, so it's just got to be less than. And then the other one is going to be pi over 3 less than t less than or equal to pi over 2 because pi over 2 is not a stopping point that we have. So now I'm going to pick an angle in this interval. And I am going to, I don't really know how that just happened. I'm going to test it and see what happens. So give me an angle between,
60.
in radians, between 0 and pi over 3. Pi over 4. So I'm going to test v of pi over 4. So 6 sine of, now remember it's 3t, so this is 3 times pi over 4, so 3 pi over 4. And what is the sine of 3 pi over 4? Root 2 over 2, so 6 times root 2 over 2, which gives us 3 root 2. Now, I just care about if this is positive or negative in terms of if it's moving right or left. So is this positive or negative? So which way is it moving? Right. So this is greater than 0, aka positive. So it is moving to the right. On this interval. So technically we would, well, I'll summarize it up in a second, but just keep that handy. And then give me an angle in radians up here. And it may not be one that you know off the unit circle.
Give you an angle what?
That's in between pi over 3 and pi over 2. It may not be a known angle to you.
Can we use pi over 2?
No, it needs to be between it. 5 pi over 12. Because it's smaller than pi over 2 and it's a little bigger than pi over 3. You got it now. That's increments of 15 degrees. All right, so v of 5 pi over 12, 6 sine of 3, here, I'm going to write it this way, 3 times 5 pi over 12, but the 3 and the 12 can reduce, so that's going to become 5 pi over 4 instead. So what is the sine of 5 pi over 4? Negative root 2 over 2, which means this comes out to be negative 3 root 2. And what is that? Moving left, it's less than 0. So I've circled everything that I need, all my critical information. So to summarize this, so just to get everything all in one spot here together. From 0 less than t less than pi over 3, it's moving right. From pi over 3 less than t less than or equal to pi over 2, it's moving left. And t is equal to 0 and t is equal to pi over 3, it is stopped. And so that is our answer to part A.
Just part of
Just part A. All right, part B. Find the particle's displacement for the given time interval. If S of 0 is equal to 3, what is the final position of the particle? All right, so now key information here that they give us is that this initial position is equal to 3. I'm still using that same interval that was given to me in the original problem, the 0 less than or equal to t less than or equal to pi over 2. So I'm now going to integrate this initial velocity function here so that I can get to what? What does integrating velocity give me? Position. So the integral from 0 to pi over 2.
So it's opposite of what we used.
Yes, derivative goes the other way. Yep. And because that 6 is just a constant, I'm going to put it out front. So 6 integral from 0 to pi over 2 of sine of 3t dt. So I need to go about integrating this. How do I do that? Nice little echo. Huh?
Can we do? I wish we could plug it into a calculator. but I just
No,
can't
you cannot plug it into a calculator. You should know how to do this by hand. How? Y'all keep saying take the antiderivative. I'm waiting for somebody to take the antiderivative.
It'll be cosine. Or
Yeah.
negative cosine.
Huh?
Would be negative cosine. Or just cosine.
It'd be negative.
For the antiderivative of sine.
Yeah, it'd be negative question.
Of what?
Um,
Uh, 3/2 t squared plus c.
There was a fancy method we learned last chapter to solve these. U substitution, yes. So what is U?
I think it'd be
3t, so then what is du?
Oh, 3.
3 G2.
Do I have a 3 in there?
You do.
That's not in the 3t.
You do not.
So what do I do?
You can find that.
So it'll be 1/3 du equals G2.
Yes. So now I'm going to rewrite this. So 6 over 3, that's going to become 2. And then the integral from, I'm debating how I want to show this to you. Alright, let me explain the two different options before I keep going. We can either keep the parameters the same, and when we're done taking the antiderivative, we plug 3t back in, and we solve it that way. Or I can get new parameters, meaning replace 0 and pi over 2, by solving them for u. So like I can go ahead and plug these parameters in for t here and get new parameters by doing it that way. So like it would look like u is equal to 3 times 0, which is equal to 0, and u is equal to 3 times pi over 2, which would be 3 pi over 2. And then I can change this, and this would be from 0 to 3 pi over 2. And we don't have to replace u when we're done.
Is that easier?
Okay.
Is that way like easier or simpler? You said.
6 1/2 dozen. I mean, it can be, but it also can be more confusing potentially. Because, I mean, anytime when we did u substitution with a definite integral, we didn't change u. But it could theoretically make it simpler because you're not replugging in at the end. So if you want to do this one like this, then we can look and see what you think. I mean, you technically know how to do this.
You're just taking the u value and substituting t in for those.
Yeah, and I won't replace u when I'm done. So, like,
Yeah,
so this is what it's going to look like. So now it's going to be the sine of u du like that. I'm going to integrate this, and then I'm going to plug in these values.
You're not gonna.
I'm not going to replace u anymore.
Okay.
So it can be easier. It might mathematically make it easier because you're not doing 3 times something, but it's the same thing is happening either way. Your answer is going to be the same either way. So this is just a different way that you might find easier. I don't know. It just depends. I hesitated earlier with if I was going to show you this method or not, but it could make your life easier, so I guess I should. So now antiderivative of sine of u.
Negative cosine.
So ultimately I'm going to have negative 2 cosine of u because I have the 2 out front, so I'm just going to go ahead and do it together. So now at this point, normally what happens is we plug back in the 3t. But because I've changed the parameters, I don't need to do that. So I'm eliminating a step of plugging back in. So I'm going to evaluate this, evaluate u for 3 pi over 2 and 0. So the negative 2 is going to be out front. Then I've got the cosine of 3 pi over 2 minus the cosine of 0. And so what is that? So that gives me negative 2 times negative 1, which is positive 2. Now, that's not my total displacement, though. Okay? Because the initial position was at 3. So, new position is equal to initial position, which was given to me, plus displacement, which is what I just found. So this value here is the displacement. So this is equal to 3 plus 2. So my new position is 5. And that's the answer to part B.
Okay. Yeah. You know exactly.
Yeah, because I had the same expression on my face when I was looking at this earlier. I was like, 3? Where did I get 3 from? Because I didn't have my book open. I was just looking through my notes, and I quickly realized that was not smart because I needed to actually know what the question was asking.
Right.
So I like pulled it out, and I was like, oh, okay, I know where the 3 came from now.
Yeah.
I was like, did I just pull that number out of my head? Like, where did that come from? Now we're on part C. This is the last part.
This question.
Find the total distance traveled.
It's not that hard. It's just
How many questions?
like I
how many types of
feel like you
questions
wanna mess
like
up
this would you put
somewhere.
on the test?
all of them.
Probably just one because it would take you so long.
It already takes us a long time.
And what we may have to do potentially is just quiz on like 2 sections and then quiz on like the last 3 or something like that.
So not do
For
like
the sake of
fast.
time so that we can just
How many
review for
more
the
chapters
exam.
do we have to get through?
This is the last one.
This is the last chapter. We just have sections.
She said-
There's a section of chapter 9 that we need to look at, but we don't have to do the whole section.
Okay.
It's just something that was missing that literally should have been taught when we did limits.
Really?
That our book doesn't teach till chapter 9, and it really irritates me. And if I had realized that,
Limits the most.
I would have done it when we did it, but I didn't
So-
know that. So we'll kind of be like backtracking a little bit.
So we're not taking a test this chapter? Or
We
something?
might. I just am saying if we're pushing it for time, I would rather you do practice tests where we can go through everything instead of testing you on
Yeah.
this kind of thing. But I'm trying to get through all the material because at the end of the day, if we get through all the material and don't get to review, at least you got through all the material and you've seen everything. Like, you can review on your own time. And, I mean, if we come in at 7 a.m. for 2 weeks straight, that might be what happens also. Whoever wants to come can come, kind of thing. So, we'll just see. Or Wednesdays after school or whatever. Not yet. Not starting yet. Absolutely not. But I might set some days, like, pre-cal won't need it because we're literally done with pre-cal. So, pre-cal won't need it, but, like, stats and calc, I might, like... Can't really do Mondays because of staff meeting, but do like different days for different things or something.
I'll say Wednesday morning is always good with me because I'm here anyway.
So, anyways, we'll see. All right, so total distance traveled. So we're gonna have to use our
I'm gonna go back and not know what
these parameters here is what we're gonna be using.
Okay.
So I'm going the integral from 0 to pi over 2 of v of t, because that's the initial, or like, that's what my overarching thing was that was given to me said. This is going to be equal to the integral from 0 to pi over 3 of 6 sine of 3t, and I could put the 6 out front, I just didn't, dt minus the integral pi over 3 to pi over 2 of 6 sine of 3t dt. And I need to verify, but I think because this one was moving left is why this one's negative.
Okay, I was wondering why we.
But I need to verify that, so don't hold that as 100% truth right now. I'm going to have to look that up and verify that. But, all right, so, again, I'm going to change I'm not going to change the parameters, but I need U substitution again. I'm going to take the 6 out of both integrals when I do that as well. So I'm going to have, again, U is 3t, du is 3dt, 1/3 du is equal to dt. So all that we already had. Now, in this one, we could go through and for each thing, we could get the new parameters here and not have to plug in u, but I'll do this one by replugging in u, 3t for u, so that we see the other option, and either method would work just fine. You would just have to do it for 2 different sets of numbers if you were going to use the other method. So it probably is easier just to plug it back in.
Okay.
All right, so I have then, if I take the 6 out, divided by 3, that's 2. So 2 integral from 0 to pi over 3 of the sine of u du minus 2 again, integral from pi over 3 to pi over 2 sine of u du. The antiderivative of sine of u we said was minus cosine, so it's going to be negative 2 cosine of u evaluated from 0 to pi over 3. Now this one, because this was minus 2 and this is going to be negative cosine, it's going to be plus 2. So plus 2 cosine of u from pi over 3 to pi over 2. And now, at this point, though, I need to replace u with 3t so that I don't forget about that, because I did not do new parameters this time. Okay, so the difference in part B and part C in the math of what I'm doing is that I got new parameters in part B. In part C, I'm truly doing u substitution and plugging back in. So now I've got negative 2 times the cosine of, I'm going to do it this way so I can bracket it off and not have to do the negative 2 twice. So the cosine of 3 times pi over 3, so the cosine of pi, minus cosine of 0, plus 2 times the cosine of 3 pi over 2, minus 3 times pi over 3 is pi, so minus the cosine of pi. So negative 2 times, what's the cosine of pi? Negative 1. Cosine of 0. So negative 1 minus 1. Plus 2 times cosine of 3 pi over 2. Zero minus cosine of pi, so that's going to end up being plus 1. So I've got negative 2 times negative 2, so that's going to be a positive 4, and then plus 2 times 1, so plus 2, so that's going to be equal to 6. So the total distance traveled is 6.
So how did you set up the V of t equation at the very top again?
So I used the parameters for left and right to do it, and then the one that was moving left is the negative one. I need to verify that that's y. I have to look that up so I can verify that, but I'm fairly confident that that's y. So I might be able to tell, actually. Yeah, it's got to be based on what the other problems I have worked out are. Alright, I'm going to start another one like this that probably will go a little faster. And if we don't finish it, we'll just do it tomorrow. But I won't write out the problem statement for all of them again. I'll just write like part A, part B, part C. So
Will these problems have the same like problem statements basically for most of them?
yeah, so like in like the initial position is going to be 3 in all of these.
Oh.
But that might be something that if I give you a problem on the test or the quiz, I might change what that initial position is to make it so that it's something a little different when you're doing it, just so that it's not the exact same problems that you have in the book, but something similar. So 4 says v of t is equal to 6t squared minus 18t plus 12, and 0 is less than or equal to t less than or equal to 2. So part A, just to reiterate, said determine when the particle is moving to the right, left, and stopped. So what was the first thing that I need to find out of those? How do I do that?
Equal to 0.
Set the equation equal to 0. So that's going to be 6t squared minus 18t plus 12 equals 0. All right, back to algebra 1. Let's take out a 6 first. Sounds like a great plan. If I take out a 6, since it's going to be 0 divided by that, it's just going away. So what happens when I take a 6 out of everything? What am I left with?
T squared minus 3t plus 2.
Yep. Equals 0. Now what?
I would move the 2 over.
I wouldn't.
And then factor out a t.
How about we just factor?
Okay.
What do I get if I just factor? Whoa, come back.
T minus 1,
T minus 1, T minus 2.
Oh, that's special type.
It's not a special
It's not
type.
special type.
It just has a 1 in front. Remember, if it had a number left in front, we'd have to use the arch method to factor it. So what's t equal to?
1 or 2.
So this is where it's going to be stopped. I might not write the concluding statement like I did last time just for the sake of time. So I'll just go ahead and box it off. So that's where it stopped. So that means my intervals, and see, notice on this one, it wasn't stopped at time t is equal to 0. So when I set this interval up, it's going to be 0 less than or equal to, whereas the other one, because 0 was a stopping value, it was just less than. So my intervals, how did I write them last time? Oh, I used different colors, that's why. So my intervals are going to be this time 0 less than or equal to t less than 1. Or the other interval is going to be 1 less than t less than 2, because again 2 is a stopping point, so I don't include that one. So I need to find out if it's moving left or right on each of these intervals. So pick a number in this first interval for us to test. 1/2, so we're going to do v of 1/2 is equal to 6 times 1/2 squared minus 18 times 1/2 plus 12. So let's see, that's going to give me 3/2 minus 9 plus 12. It's going to end up being 4.5, 4.5. Now what is that? So which way is it moving? So that means this first interval, this is moving right. And don't just assume that because one was going right, the other one's automatically going to go left. Always, always, always check it. So then, what number do you want to use in here? 3/2. So 3/2 is equal to 6 times 3/2 squared minus 18 times 3/2 plus 12. Okay, let's see. 9 over 4 times 6, so it's going to be 3/2 times, so is that 9 over 2? I think. Somebody check that. 9 times 3, so minus 27 plus 12. 27. Oh, that'd be negative 15. No. Yeah? No. Yes. Negative 15 plus 4, so that's negative 11. Negative 10.5? Question mark? I feel like that's not right. I feel like something's wrong about this math.
Isn't the first one
Negative
27
10.5.
over 2?
How much?
I think it's 27.
I think.
It definitely is. I was like, something's not right about this math.
Yeah. There's a cookie point right.
Ooh, that means y'all get cookies.
Oh wait, yeah.
We do.
I don't know why I thought it
I
was.
thought it was.
It used to be, but since I didn't start it as early, I said at 5 I had to do it. College algebra still hasn't told me what cookies they want, so they haven't gotten their cookies yet. Huh?
Oh, they said I will.
Alright, 27 over 2 minus 27 plus 12. That's more what I thought the answer should look like.
Negative 1.5.
And that's less than 0, so that's going left. So this interval is going left.
You said we're always gonna check, so is there like a case where it should be like,
I mean, I don't think any of them in our book necessarily do, but it's always good to check them because, I mean, I guess hypothetically they could. Because, I mean, after a stopping point, it could continue going the same way that it was going, but most of the time they're going to be opposites. But it's just good to verify because, like, like with this one, if we had done math wrong, like this was still going to give us a negative value, so it still would have been going left, but just kind of a way to also make sure. If they're not opposite, just look over your math really fast again and just make sure that it makes sense. So, part B, particle's displacement for the given time interval if the initial position is equal to 3. We want the final position. So this is going to be the integral from 0 to 2 of 6t squared minus 18t plus 12. What's the antiderivative of that?
Nine squared plus 12t.
And we'll evaluate that from 0 to 2. So if we plug in 2, I've got 8 times 2, so 16. Minus 2 squared is 4 times negative 9 is negative 36. And then 2 times 12 is 24. And then obviously when I plug 0 in, everything is 0, so minus 0 for that overarching final piece there. Positive 4. So then, but this is our current position. This is like the displacement value, right? So I need to get the actual new position, which remember is the initial position plus the displacement. So that's equal to 7. And then we'll do part C tomorrow because the bell's about to ring.
Wait,
We definitely
where in the
look-
problem does it tell us the initial position was 3?
And the instructions. It's the same instructions from number 2.
Because remember, so that x starts to go.
Clearly, he doesn't remember.
Also, this one was a little easier because we have